Okay, so after the Ptolemy and the Copernicus, that is in the Egypt, the concept shifted to Denmark. Okay, that is in Europe. Okay, European civilizations, that is Denmark. In the Denmark, there is a person whose name was Tycho Brahe. Okay, Tycho Brahe, he was the king of Denmark. Tycho Brahe, he was a king of Denmark, and he was a person who gave birth to the concept of astrology. Okay, astrology. What does astrology suggest? He said that planetary motion affect human life. He was the person who gave birth to a concept of astrology, and he said that motion of the planets, okay, in the solar system around in the universe, they affect the human life. The human life, okay, he gave this concept. Now since he was the king, so everyone used to believe his concept, everyone used to follow his concept that yes, in actual we can see the planets affect the human life, the motion of planets affect the human life, okay. And still at this point of time, we used to believe this concept in terms of the astrology, okay, in terms of the astrology, that yes, the planets basically affect the human life. And he basically, the two models of solar system. Now what Tycho Brahe did is, he mixed the two models of solar system. One model is that Earth is the center and everything revolve around the Earth, and second model is Sun is the center and everything revolve around the Sun. So we have two models, that is geocentric model and sun-centric model. So he mixed the two concepts, he mixed the two models. What he said is, he said that Sun revolve around Earth. Okay, he said that Sun revolve around the Earth. It means this is the geocentric model, that Earth is at the center and everything revolve around the Earth. So he said Sun is revolving around the Earth. Okay, and then he said other planets revolve around Sun. So this is basically the sun-centric model. So what he did, he said that Earth is still and Sun revolves around the Earth, and all other planets, they revolve around the Sun. So just imagine how complicated the model will become. It said that like this is the Earth, okay, this is the Earth, and the Sun is revolving around the Earth. Sun is a huge object, this is Sun, it revolves around the Earth, and all other planets, they revolve around the Sun, like this. This is one, this is second, this is third, and so on. All other planets revolve around the Sun. So he mixed the two models, sun-centric and geocentric, and he gave a new type of model, okay. And he also said Moon revolve around Earth. He also said that moon also revolve around the Earth. So in an orbit like this, the moon also revolve around the Earth. Along other planets, they revolve around the Sun. Okay. So just imagine how the model of this, the solar system, how the model of the universe, it is developed. First it comes the geocentric, then it comes the sun-centric, and then someone come and mixed both the models and give us different type of model. Okay, so what is basically happening? The concept of solar system is getting evolved. The concept of solar system is getting evolved. So Tycho Brahe, he discovered this kind of model, he gave this kind of model, and it's not the only thing that he said. He also studied the high and low tides. He also studied the high and low tides in the ocean. He also studied the high and low tides in the ocean. He studied this concept, he observed that this high and low tides are in some and the other way related to the moon. He saw that in every 15 days the moon will become full and then half and then zero and then full. So in this like full moon and no moon days, he observed that in the time of full moon there are high tides in the ocean, okay, in the water bodies, okay, in the ocean, and during the no moon day there was no tide. The ocean is totally calm, okay. So he studied this concept and he said that it is possible that moon is attracting, okay, try to understand this concept. Now from this point we will come to the point of gravitation. He said that in some on the other way moon is attracting water, okay, the moon is attracting the water bodies towards itself, and that's why at the time of full moon we can see high tides and at the time of no moon we can see low tides. So he gave this concept that after every 15 days we are able to see the full moon. So it is happening because due to the full moon we can see high tides after every 15 days, okay, after a fixed interval of time. So he said that there is some parameter or something is related between the full moon or the motion of the moon and the high and low tides, but he was not able to justify this reason, okay, he was not able to justify that how it is possible or why the moon is attracting the water towards itself. Now is it like that moon is attracting only the water, or it is attracting everything on the earth, okay, why only there is tides in the water, why we do not feel, why as a human we do not feel any attraction, why water only feels this attraction. Okay, there were some of the concepts, there were some of the questions which were left unanswered. So what happens, since Tycho Brahe was a very famous person, he was the king of Denmark, so he gave these concepts and almost everyone used to follow these concepts. Now there is a person who was very motivated, who was very inspired by learning the concepts that were given by the Tycho Brahe. And the person who was very inspired, who feel motivated to work in this field, the person was Kepler. The person was Kepler. Kepler was basically a German mathematician. What happens is Kepler goes to Tycho Brahe and become a student of him, and whatever the research, whatever the work that Tycho Brahe was doing, Kepler also supported his work. Kepler also started doing the same kind of work under his supervision. So what is happening, after the Germany, this concept is shifted to, after the Denmark, this concept is shifted to Germany. This German scientist Kepler, he became a student of Tycho Brahe and worked a lot in the field of planetary motion. He used to observe for many long hours, for 10 to 12 hours continuously, he used to observe the motion of Mars. Okay, he started observing the motion of Mars. Almost every time he tried to understand how the Mars is moving, how the other planets are moving, and based on their planetary motion, based on their orbit, based on their path, the Kepler was the person who suggested the perfect model of solar system. Kepler was the person who suggested the perfect model, the actual model. Okay, the exact motion, the exact planetary motion is suggested by the Kepler. Okay, he gave three laws which were known as Kepler's laws, and in Kepler laws he suggested how the planets used to motion around the sun, or how the planets, how the arrangement of solar system is done, and what are the paths followed by different heavenly bodies under this Kepler laws. So first to note this concept of the concept given by the Tycho Brahe and the Kepler, and then we will understand the three most important laws that were given by the Kepler, which are known as Kepler laws. Even at this point of time, we are following the Kepler laws. We are observing, we are doing our research based on Kepler laws, because the model that Kepler suggested was the perfect model. It is actually the model which resembles the universe or the solar system. Okay. So first to note this, and then we will learn the very important thing, Kepler laws. Okay, so as I said, the Kepler was the person who gave the perfect model of the universe, perfect model of the solar system, and using his three laws. So let's understand laws of Kepler. Three laws of Kepler. The first law of Kepler is very simple. It says that sun is center and all planets or all heavenly bodies revolve around the sun in elliptical orbit with sun at one of its foci. Okay, the first law that Kepler suggested is that sun is at the center and all the planets revolve around the sun in an elliptical orbit where sun is at one of its foci. Now what is foci? See, ellipse is a figure. Okay, ellipse is just like we have other figures, just like we have circle, we have square, we have quadrilaterals, we have triangles. In similar way, ellipse is a kind of figure. Okay, ellipse is something like this, and let me draw it again. Ellipse is also a 2D figure or a plane figure, just like other plane figures. If I try to draw the ellipse, it would be something like this. It is something like this, okay, in circular way. Like this, okay. This is somehow this is an approximation of ellipse. Okay, it looks like this in circular way. And in this plane figure, we have 2 points which are known as foci. Foci are 2 points like this at this position and this position, somewhere here. This is the center, and these are the 2 foci. At this point of time, just take this, that this is the foci, this is F1 focus, this is F2 focus. Okay, the plural of focus is foci. So this is one of the focus of ellipse, this is another focus of ellipse. Now what are the focus? It is not our discussion. Okay, we need not to discuss, they are beyond our scope. So just understand that ellipse is basically a 2D figure in which we have 2 points named as foci. this is focus 1 and this is focus 2. So what the Kepler suggested is that in this the solar system, it is based in such a way that sun is at one of the focus of this elliptical orbit, that is, for example, here sun is present at one of the focus, this is sun, and the planets revolve around in elliptical orbit. So for example, sun is here and here we have a planet, let's say this is the earth. So earth is like revolving around the sun in not a circular orbit but rather in an elliptical orbit. This is like an elliptical orbit. You can see if the earth is at this point, it is close to sun. If earth is at this point, it is away from the sun. Okay, it is far away from the sun. Okay, if earth is at this point or at this point, what does this mean? It means that the distance between earth and the sun is not fixed. It varies with time. It varies with the position of earth, because earth is revolving in an elliptical orbit. It's not like the earth is revolving in a fixed orbit, and due to this reason we are able to see different types of weathers, that is winter or summer or rainy. Okay, they happen because of the motion of the earth. So you can see if earth is at this point, it is far away from the sun, it means this at this point we may face winter season. Okay, and at this point we may face the summer season because earth is very close to sun. So it's like the motion of the earth, okay, changes the weather, okay, changes the climate. So this is the first law that is given by the Kepler, that sun is at one of the foci and earth or any other planet revolves in elliptical orbit. So this is the elliptical orbit. The second law that he gave is same area is swept in same time. Same area is swept in same time. Now what does this mean? It means that, for example, if a planet starts from here and move till this point, okay, considering this as the center or using this foci, okay, let us say a planet starts moving from this position to this position, okay, from this to this in, let us say, time t1. In, let us say, t1 time, the planet moves from this position to this position by swiping an area of a1, okay. If a planet moves from this position to this position and swipe an area of a1 in t1 time, if the same planet, let us say, moves from this position to this position in t2 time by swiping an area of a2, okay, he said that if there is a planet moves from this to this in t1 time and swipe an area of a1, if the same planet moves by t2 time and swipe an area of a2, then a1 upon t1 is equals to a2 upon t2. Okay, what does this mean? If t1 is equals to t2, then a1 would be equals to a2. This is the law he suggested, that if a planet moves, let us say, from this to this in 1 year, okay, or let us say in 3 months, it swiped an area a1, and in this position he swiped an area a2 in again 3 months, then this a1 and a2 would be equal. Okay, this is the second law that Kepler suggested. And the third law he suggested, it's again a mathematical law. He suggested that t square is proportional to cube of radius. What is t square? T is the time to complete one revolution. T means the time to complete one revolution. For example, the T for Earth is 365 and 1/4 days. In 365 and 1/4 days, Earth complete a single complete revolution around the Sun. Okay, the same is this T. We call this as time period. Okay, this is the time period of any planet. That is, time period means the time it takes to complete one revolution around the Sun, and R means average radius. Now what is average radius? Average radius is simply the distance of the planet from the Sun and averaged out over the complete journey. Okay, for example, the planet is here, this is the distance, the planet is here, this is the distance. If it is here, this much will be the radius, this much will be the radius. At different positions we have different distances from the Sun. If I add all them and average them, then the radius that will come will be known as average radius. So he said that square of time period is directly proportional to cube of average radius. Now what does this mean? If the average radius increases, the time period will automatically increase. And this is a very logical thing. You can understand the planet which is at more distance from the Sun will have a bigger time period, will take more time to complete one revolution. That's why, since you can see Earth take 365 and 1/4 days to complete one revolution, and if I consider let us say Saturn, or if I consider let us say Neptune or Uranus, they take more time compared to Earth. The reason is simple, they are far away from the Sun. Okay, their distance from the Sun is very large compared to distance of Earth. So that's why this law is very simple. You can understand it very easily. You can understand this law and very easily, and this is a bit mathematical. This law that same area is swept in same time interval. So these are the three most important laws that are given by the Kepler, and at this point of time also we follow this law. All the research, all the concepts developed after the Kepler were based on these laws. This concept, this model of the solar system brought a revolution. Okay, this concept explained everything. This concept basically explained every type of phenomena that is happening in the universe, or that is happening in the solar system. That is solar eclipse, lunar eclipse, or anything. Okay, name any phenomena and that would be explained by Kepler's law. So this is the perfect model of solar system. So if someone asks you what is the perfect model of solar system and who gave that model, you can simply say Kepler gave the perfect model of solar system in his three laws, which are known as laws of Kepler, three laws of Kepler. Okay, so this is basically the concept of solar system. Now after this Kepler, we will come to a very next important philosopher, that was Galileo. He was in Italy, he was an Italian person. So he gave some of the concepts, and then we will come to Newton, who brought a revolution in the field of gravitation. Okay, so first note this and then we will continue. Okay, so after the Kepler, there was again a very great philosopher. Okay, a very great philosopher in Italy, and the person was Galileo. You have heard this name many number of times. You have heard this name in many things, because the Galileo was a person, he was like all-rounder. He used to he developed some of the concepts in almost every field of physics. He discovered what is gravitation, he discovered the value of acceleration due to gravitation, he discovered the concept of velocity, the concept of displacement, the concept of acceleration. He developed a telescope, he developed the pendulum watch, he supported sun-centric model, and there are various other activities also which Galileo has done and he proved. Okay, so let us first discuss what the Galileo did in his times. He gave the concept of displacement velocity, acceleration. Okay, he gave the concepts of displacement, velocity and acceleration, which we studied in the first chapter, that is motion. We studied the concepts in motion that was given by the Galileo. He worked a lot in this field, he gave these concepts, he tried to understand the motion of any object on the earth, the motion of objects in the universe. He made a lot of contribution in this field. He also calculated the value of acceleration due to gravity. He accurately calculated the value of acceleration due to gravity, which we denote by small g. Okay, he calculated its value. And not only he calculated the value, he also challenged a concept which was given 2000 years back. Okay, 2000 years back, Aristotle gave a concept that a heavy body will fall fast on the earth and a light body will fall slowly on the earth. Galileo challenged that concept and he said that it do not matter what is the mass of a body, every body, all the bodies will fall with the same speed, with the same time, at the same time on the earth. Okay, how he discovered this? He challenged the concept. He challenged concept that heavy body falls fast. He challenged this concept that heavy body will fall fast. He said that it's totally absurd, it's not like this, that he said that all the bodies will fall with the same speed, all the bodies will fall at the same time. And to demonstrate this experiment, to demonstrate this concept, what he did an experiment. He climbed to the Leaning Tower of Pisa. You have heard this Leaning Tower of Pisa, it is in Italy, and he climbed on Leaning Tower of Pisa and he took two balls, one is iron ball and other is wooden ball, and he dropped both the balls from the same height and he noted the time in which they reached the earth. He noted that both the bodies, even the iron ball and the wooden ball, we know that iron ball is heavy, okay, and wooden ball is light ball. Both these balls reach the earth at the same time. And in this way, he demonstrated his concept that all bodies fall on earth with same acceleration and at same time if they fall from same height. Okay, what Aristotle said? Aristotle said that if I take an iron ball, if I take a wooden ball, if I drop both of them from the same height, the iron ball will reach the earth first. Okay, iron ball will first reach the earth and wooden ball will take more time. But Galileo discarded this concept and Galileo said that if you drop the same, if you drop two objects from the same height, it do not matter what their mass is, what their size is, both of them will fall on the earth at the same time. Okay, so he discovered this concept. Now what happened? Why Aristotle said that heavy bodies will fall on the earth first? The reason is simple. Aristotle also taken into consideration the air resistance. Okay, also considered the air resistance, and he forgot that the earth, okay, he forgot that the force applied by the earth do not matter what the air resistance is. Air resistance do not play any role in gravitation. So this concept was given by the Galileo, and this concept was proved true by his experiment when he climbed on the Leaning Tower of Pisa. Okay, so using this concept, Galileo accurately, calculated the value of acceleration due to gravity, and he also developed pendulum clock. Okay. Now based on this concept, he developed the pendulum clock. You know what is a pendulum clock? He developed this pendulum clock based on the same concept. Okay. We will understand the pendulum clock in the chapter when we study about waves. Okay. And after this pendulum clock, he also discovered a telescope. So Galileo was the first person who discovered the telescope. So imagine how brilliant Galileo was. He worked in almost every field of physics. He discovered the concept of displacement, velocity, he calculated the value of gravitation, he discovered a telescope, he discovered a pendulum clock, he supported sun-centric model, and there are various other activities that Galileo started. But the problem is that since Galileo always opposes the king of Italy, okay, the concept that Galileo give, they were opposite to what the king of Italy believed. Okay, and that's why the Galileo was thrown to the jail, and after some point of time he got blind. The reason is that he used to watch sun, he used to directly watch the sun using his telescope, okay, with the naked eyes. So what happened? He got blind, okay, after some point of time, because the rays that are coming from sun, they are very much powerful rays, they have a lot of energy, and because of that Galileo become blind. And what does happen is that whatever the work Galileo started, okay, the work that Galileo started, they were left incomplete, okay, they were left incomplete, and hence Galileo was not able to complete whatever the work he did, okay, whatever the work he started. Although he did this much work, okay, this is also a commendable job that he did. And what happens is, after the death of Galileo, few years back, Newton was the person who started the work done by the Galileo. So after Galileo, Newton followed and started the work from same point, okay, from same point. Now this is most important. Whatever the work Galileo left behind, okay, the Newton started the same work from the same point at which Galileo left them. Okay, as you can see, this acceleration, velocity, and displacement, they are given by the Galileo, and Newton started from Newton's laws of motion, which is just after the motion we used to study. First you study the motion chapter, then you study the laws of motion, okay, force and laws of motion, in which you studied Newton's laws of motion. So it means that whatever the work Galileo left, from the same point Newton started them too, and he continued the work. And that's why sometimes it is said that Newton is like a rebirth of Galileo. Okay, it is believed that Newton is basically a rebirth of Galileo, because he started the work from the same point where Galileo left them. So this is all about the Galileo and his contribution in the field of gravitation. Now as you can see, the gravitation, acceleration due to gravitation G, it was not discovered by Newton. Okay, Newton used the concepts developed by the Galileo. Galileo was the person who discovered this acceleration due to gravitation. Galileo was the person who first gave the concept of telescope. He developed the telescope, he used to watch the stars in the night sky, and he was the person who developed the pendulum clock. Okay, you may feel that pendulum clock is just like a clock, but it has a way back a different history and a very important and interesting concepts in physics, okay, related to pendulum clock. So these are the work done by the Galileo. After this we will study the Newton and what the Newton contributed in the field of gravitation. Okay, so first you can note this.